Hello, everyone. You are welcome to this lesson. And lesson is still on indices and logarithm, but we are looking at logarithm. Okay, on log. Okay, we know all the laws of what log. Okay, especially the core math one. Okay, we have relative math one, which is the law of touched on that. So do that okay at the right time for the relative math students. Okay, so Uh, wow. Okay, someone has drawn my attention to very important. So quickly, I think I have to go and do it. So I will pause. Okay, so like I was saying, okay, we know all the rules concerning log. One that I have shared, and because we are doing format, okay, that one is for elective math. So I will not going to mention it here, but I've mentioned that we have the law of change. The change of base. Okay, so yeah, we are going to go backwards using the two main laws, or even all the laws, the three main laws, the product law, the quotient law, and the power law. Okay, that's what we are going to, but we'll go backwards, basically. That's all that we are going to do. You can see that in all the laws, okay, you will be given a single log. It will be log of a product of two numbers. So it's just a log that, and it will now give you two terms. Okay, or log of quotient, okay, and it will give you two terms. Because log of log of x plus log of y terms. Originally, you started with one term. Log. Log of x over y, a term, and it will give you log of x minus log of y. I hope you are following, which gives us
Yes,
two
please.
terms. Okay, so it's the same concept that we are going to do. However, this time around, we are back. Okay, if you are given more than a log term, how do you write it as a single log? Okay, erase.
Mr. Hartman, please, it seems your voice is breaking.
Hello, please. It's
Hi.
my voice breaking at everybody's end.
No.
No.
What, please?
Okay, then it means erase is coming from your end. So please, if possible, reconnect. I mean, disconnect and reconnect.
But your voice is very low today.
Oh, it's lower.
Yes, please.
Okay, really. All right. So let me see if I can work on it. You can hear me.
Yes, please.
All right. Okay. So let me see. I'll work. Okay. So now, like I was saying, we are going to go backwards. That's our business for the day. We are going to look at how to write, okay, expressions, okay, more than one term log expression as a single term. Just one term log expression. So quickly, let's go and have a look at how best to deal with the questions that we have there. Okay, it's not difficult at all. Some basic, okay, tricks that I have to introduce you to, or concepts. Once you get it, okay, you can even look at the question and give us, okay, the answer. And very soon, you agree with me. Okay, so let's look at the first one. Okay, so solution question one, that's what you write first, solution. Your okay, major question number, we have one. Okay, then a minor. So we are supposed to write this, express this as a single log. So you underline this, especially the single. So meaning if your answer is not a single log, okay, you can't end there. Okay, if you end there, you won't get the full marks or even the marks. So in this case, what do we have? A. Okay, A, what are we giving? We've been given, okay, log to the base A of x. Oops. Log to the base A of x. Okay, plus log to the base A of what? Of y. Please take note, okay, of this. Anytime I've said it before, but I'm repeating it in the previous video, I said it. Anytime you are asked to write, okay, log expressions as a single log, if it will be possible, then it means all your log terms, they should have the same basis or the same base. So if I have here, the log term here, the base is A, The log term here, the base is A. Am I right?
Yes,
So
please.
these two log terms, they have the same basis. Is that clear? They have the same base.
Yes, please.
Good. All right. So once you see, then it means, okay, we can write what we have there as a single log. Okay, and that is one. Two, if you can write what you have there directly as a single log, then the coefficient of each of the log terms should either be +1 or -1. Coefficient should be +1 or -1. Is my point well made? Okay, so let's study the coefficient of the first log term here. What is the coefficient of the log term here?
1.
1, very good. The coefficient of the log term?
1.
1. Okay, so that condition is also satisfied. Okay, so take note, this is basically the trick. Okay, the log terms with the coefficient of +1, okay, the numbers that you are taking log of, they will always multiply in the numerator. They will appear in the numerator, but multiply in the numerator. Okay, when you go to the negative, I will tell you, but nothing stops me from telling you here. If the coefficient is negative, then it means the number that you are taking log of should be a denominator. So positive means it will be a numerator. Negative means it will be what? A denominator. Is that clear? Okay, so by that, this is what I mean. Okay, this will be equal to, fortunately for us, all our log terms are positive. So once your log terms positive, you can write this as log, okay, your common base, A. So your single log will also have that same base, A. Okay, and we are going to write this, you know, where we are coming from. Log, okay, x, y is what must give us this. So if you are going back, we know this will give us x, what, y. Is that clear? Or I should come again?
Please come again.
All right. So like I said, let me use exactly what I advise you to do. The numbers that you are taking log of here for this particular term, the number here is x. The number that you are taking log of here is what? Y. Is that not it? Okay, so it means, natural fact, they are not going to get a denominator. Denominator will come in where the coefficient will be negative. And here we've seen that all the log terms, the coefficients are positive. So the numbers that you are taking log of, they should multiply and appear in the numerator. You know that every whole number has a denominator, and it will have a denominator of 1. Am I right?
Yes, please.
Okay, only that you will not write over 1. It's simply understood to be there. Okay, so this will be it in terms of your single log. You then come and draw your conclusion. Okay, so therefore, your log to the base A of x plus log to the base A of y will be equal to log, okay, xy. Let me clear this. Okay, and I said even with this one, because you know the law straight away, you can use it. Okay, so now this will give you, so you are going to get xy. So if this was maybe zw, it will belong to the base A of zw or wz. Is that clear?
Yes.
Okay, we'll move on. We'll do a lot, you can see. So you get it. Okay, if you are not, by now, at least you should have 50%, okay, of your understanding in the bag. Okay, at least. Okay, so we'll add the rest. Okay, 50 very soon. So B, you leave a line, then you go to B. What are we giving? We've been given log to the base A of x minus log to the base A of y. Is that clear? Okay, so an expression we start with equal to. Okay, remember we said, check whether the bases are the same. If the bases are the same, then it means we can write it as a single log. So obviously the basis of the log terms are the same. Okay, then you check whether the coefficient of what each log term is either +1 or -1. So the coefficient of the first log term here is what? +1. Is that not it?
Yes, please.
The coefficient of your second is negative -1. Is that clear?
Yeah.
Okay, so it means we can equally write this as a single log. And we made that determination. Immediately we realized that the bases were the same. Okay, so at this point, this is all that you need to do. Okay, anytime you see negative, okay, in any of the log terms, then it means, okay, the number that you are going to take log of is a fraction. Is that clear?
Yes,
So
Yes,
to bring
please.
my fraction, in that fraction, take note. Remember we said any log term with a coefficient of +1, the number that you are taking log of should occupy the numerator. Is that not it? And in the same
Yes.
way, any log term, the coefficient being -1, that number that you are taking log of, it's okay, it should appear in the denominator. So positive, okay, coefficient, +1, the number that you are taking log of x, it should occupy the numerator. The number that you are taking log of y, its coefficient is -1, so it will occupy the denominator. Is that clear?
Yes, please.
Very good.
Yes.
Okay, so if that is clear, then we can move on to the next, okay, question. Any question before we move on to the next question? Are we all fine? Any questions? Okay, Adoma.
Mr. Hackman, please, the B, can you write it as log to the base ax all over log to the base ay?
No, you cannot. Okay, you know
Uh,
that this is not equal to log. If assuming maybe you have this from the laws of log, if we say that log to the base a of x over y is equal to log to the base a of x all over log to the base a of y. Was that the rule?
No, please.
The rule was what? Log to the base a of x minus log to the base a of y. You get it?
Yes, please.
Okay, so you cannot. They mean they have, so it means log, okay, x over y is not equal to, per the rule, log, okay, x over log y. Exactly. So if you have log x over log y, you cannot write it as a single log. Is that clear?
Yes, please.
Okay, very good. All right. So if you get that, then we can comfortably come and draw our conclusion. So therefore, as you mature, you know that this lands you at your answer straight away. So you could have done your conclusion there. Okay, so we are going to get log to the base a of x minus log to the base a of y. Okay, so it's like, obviously, like I said, we are going backwards. Okay, using the rule. The rule will give you terms. And when you go backwards, then you get just a term. Okay, so now what do? You will get is equal to log to the base a of x over what? Over y. As simple as that. Okay, so that will be it for B. Okay, the next question, Paul.
Exactly, please. The way you've written the x over y, does it mean that it should not come below the a?
Oh, you are writing it on the line. Okay, you know. This is
Okay.
you know that you know how to write. That's why I taught you. Okay, it is log. The number that you are taking log of, it should occupy the lines, just like you are writing on the line, a fraction. So it will give you x over what? Over y. But the base is supposed to come a little bit just below your line. I shouldn't touch the next line. Exactly.
Thank you. Yes.
Okay, someone equally can write it this way. The meaning is the same. Someone can write it this way. Let me extend this and write it. Log, okay, to the base a, then write x over y. Is the same. Okay, because you know, some of you use, okay, two lines for, okay, some If I am writing, someone can write 1 over 2 this way. Someone can write, okay, 1 over 2 this way. Is that clear? So someone can use 1 line to write a fraction. Okay, only that usually we use 2 lines to write a fraction. Is that clear? And there is nothing wrong. Afa?
Yes.
Okay, good. All right, so now let's move on to the C. Okay, quickly. Any questions? Any more questions? So let me, oops. Okay, so it means we are all fine. We thank God. Okay, I wanted to clear this and give room for the C. Okay, let me see if I can do the C. Okay, on this side. Okay, so C. I'm going to do the C here. C, what are we giving? Log to the base A of X plus log to the base A of what? Y plus log to the base A of what? Of Z. Okay, so this time around, how many log terms?
3.
3. It's the same concept. So you check all your log terms, check whether they have the same basis or the same base, and they have the same base, AA. So it means you can write it as a single log. So you come and write it as equal to your log, your base, your common base A. Okay, and remember we said, check whether your terms, your log terms, okay, the coefficients either +1 or -1. Okay, so you can see that all of them +1, is that not it?
Yes, please.
When you have all of them positive, then it means, okay, your denominator of your fraction is 1. So we won't write it. Is that clear? And your numerator, okay, of that fraction will be the product of all the numbers that we are taking log of. So x times y times z. So that will give us what? Log of what? X, y, z. All correct.
Yes, please.
Okay, very good. So what then do? You draw your conclusion. I've told you that you could have drawn your conclusion at this step. Okay, so log to the base A of x plus log to the base A of what? Y plus log to the base A of z is equal to log to the base A of what? X, Y, Z. Okay, so that will be it for C. Now let's go and look at the D. Okay, if you are following, then you are doing well. Okay, all right. So please make sure you follow, because certain log expressions that will be asked to simplify. Okay, you need a single log, okay, concept to deal with it. That's the more reason why I'm walking you through what you have here. So now what do we have? D. D, what are we giving? We've been giving log to the base A of x plus log to the base A of y, then minus log to the base A of z. Am I right?
Yes, please.
Very good. So that's an expression we start with equal to. Are the bases the same of all the log terms?
Yes, please.
So it means we can write it as a single log. So as a single log, you write log to the base A. So you are waiting for the number that you are taking log of. So let's see. Coefficient, okay, of the first term +1, second term +1, third term -1. Am I right?
Yes, please.
So the coefficient is that +1 or -1. So immediately you see one log term with a coefficient of -1, it means your denominator ceases to be 1. So you are going to bring your fraction. Okay, in your fraction, the numerator will be occupied by the product of the numbers that, okay, you are taking log of with the coefficient being positive. So it will be positive coefficient is the first one, so x. Second one, y. So x and y will multiply in the numerator. Is that clear?
Yes, please.
And the z here, 3 times your denominator. All correct.
Yes, please.
Okay, my professor, is
Sir.
everyone following?
Sir,
Yes, please.
sir, please can you please go through again?
Okay, so I said, I realized that anytime your coefficient is -1, the number that you are taking log of, okay, should occupy the denominator. If it's positive, they should occupy the numerator. However, they should multiply occupying the numerator. If you have more than one, they should multiply occupying the denominator. If they are negative, is that you get it? So negative denominator, positive numerator. All correct. So this one, these two, you can see they are positive. So they are coefficient positive one. So the numbers that you are taking log of should occupy the numerator, but they should multiply, okay, in the numerator. So x times y, which will give you xy. This coefficient -1, they should come down the denominator. As simple as that. So you draw your conclusion. Therefore, okay, log to the base a of what? X plus log to the base a of y minus log to the base a of z is equal to log to the base a of what? Xy over z. Okay, so now, okay, the last one, the e, which will be for all of us. Okay, so then I think the F will be for you. Okay, so what do we have? Okay, with this one, giving, what are we giving? Log to the base A. Okay, so sorry, it's not log to the base A. It's a common log. So the base is what? What do you think is the base?
10.
10. Very good. All right. So log A, common log of A minus common log of B. Okay, plus common log of C, then minus common log of D. Okay, so straight away, I know this will also give me common log. The base is 10, I will write it just as it wasn't written. Is that clear? Okay, so you can see positive coefficient 1, negative coefficient 1. Okay, so immediately you see that it means you are going to get a fraction. Is that clear? So in that fraction, every fraction you have numerator, denominator. So how do I get my numerator? And we said the numerator will come from the log terms that will have positive 1 coefficient. So this is one of them. And this is also another one. Is that clear?
Yes,
So it
please.
means these two numbers, A and C, okay, they will occupy the numerator and multiply. So it will be A, C. Is that clear? Okay, again, when it comes to negative, you know that negative numbers that you are taking log of should occupy the denominator. So negative, two of them. So it means you are going to get two numbers that you are taking log of. One is B, one is D. So they should also multiply in the denominator. Afa.
Yes, please.
And fine.
No, please.
Okay, who said no? Hello, who said no?
Mr.
Adoma,
Hackman, please. Yes,
Adoma, is
please.
that you?
Yes, please.
Okay, where is Ali? Can you know yes?
The E, where you got AC over BD when we actually have three negatives.
You have how many negatives?
2.
Yeah, we have two negatives. So once you have two negatives, then it means you are going to get two numbers multiplying the denominator, which will be B and D.
Yeah, that's the part I don't get.
Okay, so Adoma, this is so easy. Okay, anytime you're dealing with single log, okay, you have a numerator and a denominator. Is that clear? A numerator will be occupied by numbers, denominator will be occupied by numbers. All correct.
Yes, please.
Okay, so how do I get my numerator numbers? How do I get my denominator numbers? And I said, this is it. All your log terms with positive coefficients, the numbers that you are taking log of, they will appear in the numerator. All the log terms with negative coefficients, the numbers that you are taking log of, will appear in the denominator, but they will multiply in the numerator, multiply in the denominator. So wherever they are appearing, they will multiply. So if I take this positive 2, okay, this one is also positive. If you take this, which number are you taking log of? If you take log A, which number are you taking log of?
C.
Like mine. it is A. You know, anytime you have log 2, sorry, if you have log 2, are you not taking log of 2?
Yes,
So it
please.
means the number that you are taking. What did you eat this morning? Or you've
I'm
not
not
eaten?
eating.
Okay, then I'm giving you permission to go and eat and come.
Mr. Hackman.
No, I'm pulling your legs. No, don't take it first time. All right, okay, so this is it. You know, I said the numbers that you are taking log of, they will be occupying the numerator and your denominator. So I've seen your problem. You are unable to determine the number that you are taking log of. That's your problem. So now you know. You get it?
Yes. Yes.
So if you come to this second log term, which number are you taking log of?
B.
So this one, which number are you taking log of?
C.
C. So the positive ones, the numbers that you are taking log of, they will multiply in the numerator. So A, okay, positive. C, positive, they will occupy in the numerator. B, negative. D, negative, they will occupy in the denominator. Is that clear?
Yes, please.
Okay, clap for yourself.
Okay,
all right. Okay, so let's see. Adma, I want you to convince me that you've understood. Let's look at the F. Give me the answer for F. You're all going to try so that if she's wrong, we can make that determination. Is that clear? Okay, so you can look at it now. Once you get all your log terms, okay, positive 1, minus 1, you can write the single log by looking at it. Okay, so Aduma, let's see. What do you think the F will be?
Okay, please, I think it will be log A over B, C, D.
As simple as that. So you can see that's why I was worried you didn't get it. It's so easy to get it. Please, are you all with me? Okay, so if that's the case, then I'm not going to do that of the F. Are you fine?
Yes, please.
Okay, very good. So A, the coefficient is positive. So once you have one negative term, your bar will come, your division bar, indicating your numerator, denominator. A, numerator, positive. B, C, D, all of them negative. So denominator, simple as that. Okay, so now we are moving on to our next set of questions. Okay, it's going to be a letter, but no problem. You can see that from our first set of questions, you realize that all your log terms is either positive 1 directly or negative 1 directly. Is that not? But here, that is not so. You can see the coefficient, okay, of a log term not being 1 or minus 1. Okay, so quickly, let's look at how to deal with that one. Okay, it just means you have to do a little more work, because if you can write it as a single log, the coefficient must be either +1 or -1 directly. Other than that, you cannot. Okay, before that, but you have to compare or check the log, the basis of the log, if they are the same, before you come to the +1 or -1. Okay, so quickly, let's go and have a look at the solution. You are doing well, keep it up. All right. Okay, so please, no one should hide, okay, his or her problems. You can see that Adoma did not hide. So because of that, she has solution to her problem. She now understands. So she is making progress. All right. Okay, so now let's see. So solution to question 2. Okay, 2, you have a baby A. Let's see, a single log, so you underline. Until it's a single log, we don't move. So giving the extract, what are we giving? The first one is 2 log to the base A of x. Okay, plus the second one is 3 log to the base A of y. Am I right?
Yes, please.
Great. Okay, so at this point, this is all that we need to do. An expression will start with equal to. The bases are the same. Once you have two log terms with the bases being the same, then it means we can write it as a single log. Okay, however, if you can write it directly as a single log, then the coefficient of all your log terms there either should be +1 or -1. However, if you take the coefficient of your first log term, what is the coefficient?
2.
The second log term, what's the coefficient?
3.
3. So it means, okay, that we cannot directly write it as a single log. We have to make sure that the coefficient is either 1 or -1. So it's our business to make sure that the coefficient is -1 or +1. So here, because the coefficient is positive, it means we can make it the coefficient, or we can make the coefficient +1, only that it's +2. So you know, this 2 here came because it was a power of the x. Do you know that? The power rule.
Yes, please.
So we have to take Zacchaeus back because we don't need Zacchaeus there. You get it?
Yes, please.
Okay, so we are going to write this one as log to the base A of x squared. All correct?
Yes, please.
And likewise, this one will be log to the base A of what? Y what?
Cube.
Cube, very good. So now the coefficient +1 +1. So it means we can write it as a single log. So as a single log, we write this as log. What is our common base? A. Okay, and you can see that all your log terms are positive. So it means your denominator will be 1. Is that clear? So you won't write it. There is no denominator, okay, except 1 because there is no negative term. So it means we are going to get what? This log, the number that you are taking log of in this term is s squared. The number that you are taking log of in this term is y cubed. So it means it will be s squared times y cubed, which will give us s squared y cubed. Afa. Hello,
Yes,
is
please.
my point well? All right, okay. Then what do? You come and draw your conclusion. All correct. Okay, so I'm going to skip. Okay, you know you are supposed to draw your conclusion. Okay, then we come to a B. You leave a line, then you come to B. B, what are we giving? We've been giving log to the base A. Okay, plus what? Half. Okay, log. Oh, did I say log to the base A? It's not. Okay, so the base is 10. I didn't see right. Okay, consider my age. Okay. All right. Okay, so now this is what we have. We are going to get is log A plus half log B. So common log of A, common log of B. All right. So here, again, let's look at our log terms. Okay, they have the same basis, am I right? Or the same base. Okay,
Yes,
which is 10. So means it is very likely, in fact, I can write it as a single log. Okay, however, if I can write it directly as a single log, then each log term, the coefficient should be either +1 or -1. So let's look at this first one. The coefficient is what?
1.
+1. Okay, the second one, coefficient is what?
Half.
Half. So, but for the second term, you could have written this one, okay, directly as a single log. So it means the second term, you have to work on it. So the half here, remember, was the coefficient of the B. So, sorry, the power of the B exponent. So you bring it up. Is that clear?
yes,
Yes.
please.
Okay, so
Yes.
this one, you keep it. Okay, it is in the form that you want already. So log A. Then plus, this will give us, okay, B to the power half. So it will be log, okay, B to the power half. As you mature, you know B to the power half is better you write it as root of B. Is that clear? But it doesn't really matter if you write it as B to the power half and conclude with B to the power half. It will give you right. Only that usually if it's to the power half, we'll use the square roots. Okay, so in this case, I can now write it as a single log. So this will be equal to my single log. Also have the base of the common base of 10. I will write it. So all of them positive, is that not it?
Yes.
Yes.
So it means your denominator will be 1. Is that not it? It will be 1. But your numerator will be these two numbers multiplying. So it will be a e to the power, okay, half. But like I said, in my conclusion, I'll write it the matured way. So log to the base a plus half, okay, log to the base b. Okay, this will be equal to log to the base. Okay, yeah, did I say log to the base b? Log b. Okay, so log a. So this will give me log, okay, to the base of 10. That's a common log of a root of b. Is that clear? Because b to the power
Yes.
half is the same as the square root of b. Okay, Amma.
Is that conclusion? It must be explicit.
Come again.
Is that please? I thought you said the conclusion should be explicit.
A conclusion for what should be explicit. Okay, remember I said when you are dealing with indices, okay, your exponent should be explicit. But we are not dealing with indices, we are dealing with log, though they are strongly connected. So if you are dealing with indices and you are drawing your conclusion in indices, your exponent must be explicit. So you are right. Only that we are not dealing with indices. You get it?
Yes, please.
Okay, very good. And in indices, usually we say that your exponent must be explicit. Because if it's explicit, you will know that you can combine it with another base with the same. That's the more reason why we advise that you write it as a power. Okay, you make it explicit rather than using the root and the cube root, what have you. Is that clear?
Yes, please.
Okay, all right. Okay, so now that will be it for B. Okay, so you are going to do C and D together. Okay, then we'll move on to the last, okay, question. Let me see whether, okay, oh, we are on track. Okay, so C. What are we giving? 4 log A minus 1 over 3 log B. So base is the same, log base 10, common log. Okay, so it means we can write it as a single log, but you cannot write it directly as a single log because coefficient of your first one is not 1. Coefficient of your second one is not plus 1 or minus 1. So this is what we are going to do. Now we are dealing with a negative coefficient. So it's the same concept. Okay, so what do we do here? The coefficient here, okay, we are supposed to take it up. Okay, so we are going to get this the same as log to the base A. Oh, why am I saying base A? Okay, so common log. Okay, so take notes, forgive me. All right, so common log to the power 4. Am I right?
Yes.
Okay, then minus. Remember, I said if it's negative, keep the negative. Okay, and move this one up. So that will give us log, okay, B to what power? 1 over 3. Am I right?
Yes, please.
Okay, so in effect, here you have a positive log term and a negative log term. So if you are writing it as a single log, okay, you are going to get a fraction. The denominator now ceases to be 1. So your bar must come. Is that clear? So in this, your fraction, okay, your numerator will be occupied by a to the power 4. Do you agree? And the denominator will be occupied by b to the power 1 on 3. Hello, are you following my professors?
Yes,
Yes.
Okay, so here maturely, I will conclude. Okay, so therefore, 4 log a minus 1 over 3 log, okay, b will be equal to, now I'm going to get log, okay, a to the power 4. I have no special way of writing it. However, this one, I can write it as cube root of what b. Is that clear? Is my point well made? Hello, my professors, can you hear me? Is my point well made?
Yes.
Great. All right. Okay. So a D, okay, you have one, okay, which maybe will be given to you as don't know whether we'll look at it as a class record. So the D, you move this one up, move this one up, move this one up. Okay, so this one will give us log, okay, cube root of X. Do you agree?
Yes, please.
Or S to the power 1 over 3. And this will give us y squared minus, okay, log y squared, then minus log root of what? Z, or Z to the power half. Okay, so if you are writing this as a single log, then you are going to get log, okay, then your division bar will come, indicating your fraction. In that fraction, your numerator will be cube root of X, but your denominator will be y squared, the root of what? Z. Do you agree?
Yes, please.
Okay, all right, as simple as that. So by inspection, you've been able to do that. If you can't do it by inspection, you know what to do. If you're able to do it by inspection, then it means you arrived. Now let's go and look at our
Mr.
next set.
Hartman,
Yes, please. Should we do it together?
so please, no, is it? I wanted to ask a question.
Okay, so you've changed your mind.
Say, so they see like this. Is it because you don't have to conclude with a negative exponent? That's why we rather made it cubic root of b.
No, it's not about the negative exponent. Okay, we have a special way of writing, okay, a certain, we said that's why the root came from end roots of A. We said it's equal to A to the power 1 over N.
Yes,
Is that
please.
not it? So if you are not dealing with indices, then you have to take it back. You get it? So if I have,
Yes.
anytime I have A to the power 1 over 5, I'll rather write this one as fifth root of what? A.
Okay. Okay.
All right. If I'm dealing with indices, then I have to write it this way, because you know that in indices, okay, we'll be adding the exponent, multiplying the exponent, and okay, subtracting the exponent. So the exponent is explicit. Okay, for you
Okay.
to add, that's the reason why we write it in that.
Okay. Okay.
Okay,
Thank you.
great. Otherwise, in any other, okay, if it's not indices, okay, take it to its primary form. Okay, great. Okay, so ask questions. I like that. Okay, so now I think we are good to go. So in actual fact, this was supposed to be a class, okay, assignment. Okay, but because of time, let me see if you're able to do the other one, then I will give this one to you as a class assignment. So please take note. Okay, so quickly, let's move on to, okay, this, how to simplify. Okay, this is my target. So all that we've done is because of questions of this nature. Okay, all right, so quickly, now I know we are all experts in writing log expressions as a single log. Okay, because no one has complained so far. Okay, all right. So now let's go and look at what the solution to this one. Again, we are asked to simplify. This time around, you can see, unlike the previous one where we were dealing with letters, now we are dealing with actual values. Is that clear? So specifics. The other one we're dealing with general. All correct?
Yes, please.
Okay, so solution, you come to question 3. Okay, then simplify, so you know. A. Okay, we extract what we are giving. So what are we giving? We are giving log to the base 2 of 8, okay, plus log to the base 2 of 16, then minus 4 log to the base 2 of 2. All correct?
Yes, please.
Okay, so remember I said it's not only one way. I'll give you an alternative way to this, especially where you realize that your numbers that you are taking, okay, log of each of them, you can write it as, okay, your base to a certain power. Okay, so in this case, I'm going to go the single, okay, log expression form. So this will be equal to, okay, remember, if you can write it as a single log, then all your log terms, the basis must be the same. Is that not it?
Yes, please.
Okay, so here, all your log terms, they have a base of what, 2. So it means we have a common base. So we can write it as a single fraction. However, if you can write it as a single log, forgive me, if you can write it as a single log, then all your log terms, the coefficient should be what?
Either one or negative one.
Perfect. Okay, so if you know this, then I think, okay, I should be very happy. So at this point, what do we do? Okay, this one, the coefficient is what? What is the
1.
coefficient? Positive 1. So it is of the form that you want. What about the second log term?
1.
1. What about this? Is it satisfying?
No, please.
No. So we have to take Zacchaeus back. So we are going to have log to the base 2 of 8. We keep this one. It's in the form that you want. Log to the base 2 of 16. Okay, then minus log to the base 2 of 2 to the power 4. All correct?
Yes, please.
Okay, so this will be equal to log to the base 2 of 8 plus log to the base 2 of 16, then minus log to the base 2 of 2 to the power 4 is 16. Am I right?
Yes, please.
Okay, so at this point, tell me what you will do. Look at it critically and tell me what you will do. Are you, at this stage, are you going to continue to write it as a single log?
No, please.
So what will you do?
Subtract the like terms.
Very good. You combine like terms because you can obviously see like terms. It's when you don't obviously see like terms, okay, that you have to continue with your quest in writing it as a single log. So in your process, your steps in writing it as a single log, this time around, you came along what like terms, okay, along the line. So in this case, you can see that this and this will, okay, cancel. Am I right? They are equal. They are alike and equal. So it means what I have here will be equal to log to the base 2 of 8. Is that clear?
Yes, please.
Okay, which must be equal to, because you can write this your number that you are taking log of, okay, as a base of 2 to a certain power. Okay, so we have to proceed. So it will be 2, okay, then you get 2 cubed. Am I right?
Yes, please.
Okay, so that will be equal to, bring this one down. So you get 3 log to the base 2 of what? Of 2. Okay, so in effect, you are going to get 3 into what? Into 1. All correct?
Yes, please.
Okay, which will
Yes,
be equal to what? So you can draw your conclusion here. Or, okay, you now come and draw your conclusion. It's my point well made. Therefore, this is equal
yes,
to
please.
equal to 3. Afa.
Yes, please.
Okay, great. We are going to do that of the B, okay, equally together.
Sir.
Okay, however, I remember I told you I'll give you an alternative. Yes, please.
Come, sir.
Yes, please. I'm here.
Sir, please, where did the 1 come from?
This one.
The 3 into bracket 1.
One. Where did you go? Where are
I
you?
was here.
Where are you also coming from?
No, like
No, I'm pulling your legs. Okay, all right. Okay, you know, we've been using this all this while. Log to the base 2 A of A is 1.
Okay. Okay.
Okay,
Okay.
so welcome back.
Okay, thank you.
All right, okay. So now what do we have? We are going to move on to the B. Okay, all right. So B, what are we giving? We've been given 2 log to the base 10. The base is written of 5. Okay, minus half, okay, log to the base 10 of 16. Okay, then minus 4 log to the base 10 of 2. Oh, I said I was going to walk you through the, okay, alternative. Okay, let me ease it here. Now, okay. we need to play with our concept. It makes that better. Okay, so let me clear the side and come and write it here. Oops. All right. So
Mr. Hackman.
yes, please.
Mr. Hackman, please. Your voice keeps increasing and decreasing. Sometimes I do not hear what you say.
Okay, all right. Okay, I said, okay, before I wrote the B, okay, or before maybe, yeah, someone asked the question or said that she didn't know what happened here. I was going.
Hello.
Can you hear me?
Mr. Hackman, please. No, I just wanted to draw attention to that.
Is it better?
No, it has decreased.
Oh, really?
Yes, please.
Is it better?
No,
No,
please.
please.
Your voice is very faint.
Very faint, very. Okay, so let me see.
Mhm.
Okay, so give me some few seconds and let me see if it works. Okay. Hello, is it better?
Yes, please.
Okay, all right, then let's proceed. Okay, so I cleared that. I was saying that we are going to look at an alternative method, okay, to what we have here. So odds. Okay, so immediately you see, so you extract, whatever you extract here will be equal to, just to save time. Immediately you see that your basis that you have of your log, the numbers that you have there, you can write it in such a way that they will have the same base as your base here. Okay, it is not necessary to write it as a single fraction or as a single log, I should say. So I will now come and write this as log, log to the base 2 of 2 cubed. Okay, then plus log to the base 2 of 2 to the power 4. Is that not it? Okay, then,
Yes.
okay, minus 4. I know that this will give me 1. Is that not it?
Yes, please.
Okay, so I can bring the power down, which gives me 3 log to the base 2. Okay, plus bring the power down, 4 log to the base 2 of 2. Okay, let me write it well. Then minus your 4. Okay, so now you are going to get, this will give you 1. So it will be 3 to 1, okay, plus 4 to 1, and minus 4. This 4 and this 4 will go. So you still get 3 times 1, which is 3. You get it?
Yes, please.
Okay, very good. Okay, so that was just by the way. Okay, so that's the beauty of mathematics. So at this point, what do we have? This will be equal to, do we have a common base? 3 terms, three log terms, a common base of 10, right?
Yes, please.
Okay, very good. So once we have this, then we are more than good to go. Okay, so let's see. You can see that here, okay, unlike the other one, that's the numbers that you were given, okay, we could write it as a base of 10 to a certain power. Okay, here we cannot. Can you see that? So it means
Yes.
this alternative approach wouldn't work here. So it is the single fraction approach that will work, or single log, okay, approach that will work. So you can see that the single log works for all, but the other one has its own shortcomings. So it will be ideal for us to know the single log, okay, one. Okay, so let's go and use the single log. So we cannot write it already as single log because none of the log terms, okay, satisfy the situation that we are looking for. So we are going to get log, okay, to the base 10. You take this one up, so that will give you 5 squared. Then minus log to the base 10 of 16 to the power half, which is the same as root of 16. Is that clear?
Yes, please.
Okay, then minus log to the base 10 of 2 to the power 4. Is that clear? Okay, so this will give us log to the base 10 of 5 squared, we know is 25, all correct.
Yes, please.
Then minus log to the base 10 of root of 16. 16 is a perfect square, so that will give us 4. Then minus log, okay, to the base 10 of 2 to the power 4. 2 to the power 4 is what? 16, am I right?
Yes, please.
Okay, so now coefficient either +1 or -1. So we can write this as a single log. So you get log to the base 10. Okay, you are going to get a fraction because you can see positive and negative. If all of them, okay, were negative, you still get a fraction. Only that in that fraction, your numerator will be 1. You get it? Just as if all of them were positive, your denominator will be 1. So if all of them negative, your numerator will be 1. And if your numerator is 1, you need to write a fraction and write a 1. And if your denominator is 1, you don't need to write a fraction and write a denominator 1. No, simple math. Is that clear? It's simply understood to be there. So now my numerator will be occupied by 25. Do you agree?
Yes, please.
The denominator will be occupied by 4 and 16, but they will multiply. So it will be 4 times 16. All correct?
Yes, please.
Okay, so here we check if you can reduce before you multiply. Remember when we did order of operation? Okay, I told you this. So can we reduce? No.
No,
So we have
please.
to multiply. So you get 25 over
64.
64. This is how far you can go. Immediately you go beyond this, you will need your calculator. And usually questions like this, you are not supposed to use your calculator. Is that clear? Okay, so now the last question for all of us, okay, which will be the C. If you are able to do the C, all the information that I will give you, you will need it to do your assignment. Okay, so you should be able to. Wow, I have some few minutes. So C, okay, what am I giving? I've been given 1 over 2, okay, log to the base 10 of what? 25 over 4. Okay, then minus 2 log to the base 10 of what? 4 on 5. Okay, but that's not all, plus log to the base 10 of what? 320 over, okay, 125. All correct. Okay, so now we are mature. So this will be equal to, we know, okay, that coefficient should be +1 or -1. The bases are the same, so we can write it as a single log. Use that concept to simplify. So what do we do? Just like if I give in multiple fractions, if you can simplify multiple fractions, what do? You write it as a single fraction. Is that not it?
Yes.
The same thing, multiple log, you write it as single log in your simplification. So now we are going to get log, okay, to the base 10 of root of, okay, 25 on 4. Am I right?
Yes.
Yes,
Or
please.
25 on 4 all to the power, okay, half. Then minus log the base 10 of what? 4 on 5, okay, squared. Okay, plus, okay, log to the base 10. This can be reduced. Reduce it for me.
64 on 25.
Okay, so the inverse of what we had, our result, our previous result. Okay, now, do you see anything wrong with what I've written there? If yes, what is wrong?
Yes, please.
Okay, Blaze, what is wrong?
Please, the 4 over 5 square.
What is wrong with it?
Please, you're supposed to bring brackets. It's only
Perfect.
multiplying.
Perfect. Okay, clap for yourself. Okay, so if you don't bring the bracket, the meaning will be different. So please take notes. If you fail to bring the bracket, the equal to it will not be valid. Because with this one, the 4 is affecting only, the square is affecting the 4. So it will be M0, marking becomes easy A0. All correct. Even if you proceed and do the right thing. Okay, this is wrong. So the rest that you are doing is not math, magic. Okay, so now let's go. This will give us for log, okay, to the base 10, root of 25 over root of 4. That will give us 5 on 4. All correct.
No.
So it will give you what, 5 on
2.
Very good. Okay, so you are following. And let me be mindful. I think this one, it wasn't, okay, a trick. Okay, I got it wrong myself. Okay, all right. So minus, okay, log, okay, to the base 10 of what? 16 on 25. Am I right? 10 plus log to the base 10 of what? 64 over 25. All correct. Okay, so now all your log terms, coefficient either +1 or -1. So we can write it as a single log. So you have your single log, the base of 10. Okay, now, once you have one of the log terms being negative, it means your fraction bar must be indicated. Is that clear?
Yes, please.
Okay, so your denominator is equal to 1. So you have to show your denominator. So at this point, the numerator numbers that will multiply will be 5 on 2 because the coefficient here is positive, and 64 on 25. Do you agree? Coefficient positive. Do you agree? So I'm going to write 5 on 2 times what? 64 on 25. And your denominator will be 16 on 25. Do you agree?
Yes.
Okay, so now this one is just order of operation. So log to the base 10. Okay, your fraction. You check if you can reduce. You reduce before you multiply. So 5 will go here, what? 5. Is that not it?
Yes, please.
2 will go here. So simplify the numerator and give me the numerator value. Fraction before we change this bar to the division symbol and therefore to multiplication. Quickly, our time is almost, in fact, it's up. Okay.
32 over 5.
You had what?
32 over 5.
32 on 5.
On 5. Okay, so I'm going to get this to be equal to log to the base 10 of what? 32 on 5 times 25 on 16. Do you agree?
Yes, please.
Okay, so now 5 will go here too. 16, sorry, will go here 5. 16 will go here too. So we are going to get log to the base 10 of what? 2 times 5, which will give us 10. Am I right?
Yes, please.
Okay, so in effect, okay, your number that you are taking log of is the same as your base. So it means that will give you 1. All correct.
Yes, please.
Okay, so you draw your conclusion. So that will be it. And this will be your assignment. Is that clear? You use the same concept. Okay, so I'll put it on the platform and give you your deadline. Okay, clear answer.
Mr. Akman, please can you go back? Yeah, I wanted to take a screenshot.
Okay, all right. I knew it, so I went back immediately. Okay, all right. So thank you very much for asking questions, making the class interactive. Okay, please make sure, okay, if your understanding is not up there 100%, okay, go through a video that will be sent to you. Okay, and use it to do the assignment. As for the assignment, we are all getting it right. Okay, we are all getting it right. Okay, so on this note, okay, yes, please.
Can you move to the other slide?
Before or after?
Before this.
Before this one. Okay.
This. Yeah, thank you. I'm good.
Okay, all right, so you are good. Okay, so I'll put your assignment on the platform as usual. Okay, so this is it. I'll put it on the platform. Okay, so thank you very much. Okay, bye-bye. Enjoy the rest of your day. Please take care.